the resistance of this whole thing is probably to be measured in the hundredths of an ohm if we had the measuring instruments that would go that low. So with the resistance of a few hundredths of an ohm, I know we'll get several hundred amps because our capacitors will charge up to maximum voltage of about 185. So we should get several thousand amps when we do trigger the thing. And because of the near proximity of the computer monitor and of the television set, we definitely won't want to do this indoors. We'll do this outdoors a good 100 feet away from the house to make sure we don't magnetize anything by accident. But this is a completed coil assembly. It's put together using quite a few of these cable ties. It's pretty strong mechanically, and it might need to be. Well, back to the coil assembly. Now that I've thought about it for a minute, we're only dealing with about 7 feet of number 6 cable here, or wire. So I don't think it'll be hundreds. I think it'll easily be thousands of amps in this case. I think our resistance will end up actually being a couple hundredths of an ohm. So I think we'll get plenty of current. So I think the next shot we're going to do is going to be the outdoor shot, and let's get our date and time here. And our next shot will be the outdoor shot. We'll probably do it sometime tomorrow. Hello there. It's the next day. It's now October the 7th. And we've got the equipment set up outside, and this is basically what we got. Okay, on the stool we have the rat trap switch. We have a completed coil assembly. Behind it we have the capacitor bank. Yep, that's right, the capacitor bank, all 100,000 microfarads over. She's charged up to almost 170 volts and ready to go. On this first shot, I'll fire it with the stick. I don't know if it'll crush the can or not. It takes a lot more power than what I have. Although the people on the internet, when they did their experiment, I think they still had the liquid in it. Maybe mine will be a little easier. Anyway, we'll go ahead and fire it and see what happens. .7 volts. We're ready to fire. Made it jump. Good results. May not crush it, but it sure did ring it. Go ahead and reset it and fire it this way one more time. Okay, I think I'll dry fire it, see if it jumps without the electric power. See if it rings the can. Hardly even moves anything. So the ringing and the jumping of the can was definitely electromagnetic action. Now let's see. Okay, we'll charge it back up and we'll fire it this way one more time. Okay, here goes. Yeah, it made the can warm too. This time I have a steel tube. This is actually a heating element wrench for water heater repair. It may launch this, so when I fire this one I'll have to be careful. If it goes up, I don't want it to fall on my head. It's about 1.5 inches in diameter, probably about 4 inches tall. Looks like it weighs about half a pound. Give it about another minute's worth of charging time. We're sitting at about 165 volts. How about that? That was fun. Not too dangerous either. We can repeat that. We'll definitely do that one more time. We'll reset the switch. Okay, we're ready to fire one more time. And here goes. Yeah, it's fun. Okay, so we couldn't crush the can, but we could sure make it ping real loud. And the little water heater element wrench It did accelerate a pretty good little amount and jump out of there, so it was pretty successful. We don't exactly have the world's highest energy power system here, so it was a lot of fun.